Since childhood, you might have observed clouds in the blue sky, but you never have imagined that these clouds are also of different types and their formation, their potential also differs. As a student of geography, you should understand what are the different types, formations and potentials of different types of cloud. Today I am going to explain clouds, their types, formations, their potential and precipitation. How they are formed and how they are distributed. When it comes to defining clouds, clouds are defined as aggregate of innumerable tiny droplets, ice particles or mixture of both in the air, generally above the ground surface. In other words, a cloud is a hydrometer consisting of minute particles of liquid water or ice or of both suspended in the atmosphere and usually not touching the ground. It may also include larger particles of liquid water or ice, as well as non-aqueous liquid or solid particles such as those present in fumes, smoke or dust. Clouds are made up of condensed water droplets, ice particles or a mixture of both, as I explained earlier, suspended in air. Liquid water turns to ice at 0 degrees centigrade, but when water is dispersed as tiny droplets in clouds, it can remain in liquid state at temperature far below freezing. In fact, clouds consist entirely of supercooled water droplets at temperature down to about 12 degrees centigrade. As clouds' temperature grow colder, ice crystals begin to appear. The coldest clouds with temperature below 40 degrees centigrade occurs at altitude of 6 to 12 kilometers and are made up of entirely ice particles. So clouds play a complicated role in temperature, both cooling and warming the earth and atmosphere. That is the reason we should understand their mechanism. They influence the heat budget of the earth and atmosphere as they reflect, absorb and diffuse some part of incoming solar radiation and absorb some part of outgoing long-wave terrestrial radiation and then radiate it back to the earth's surface. Now I shall explain you the cloud formation. Cloud particles grow around a tiny center of solid matter. This dust speck of a matter called a condensation nucleus typically has a diameter between 0.1 and 1 micrometer. The surface of sea is an important source of condensation nuclei. Droplets of spray from the crest of the waves are carried upward by turbulent. Nuclei are also thrown into the atmosphere from polluted air over cities where particulate matter and soot aid condensation and the formation of clouds and fog, thereby increasing rate of precipitation. So let me explain you the classification of clouds. Clouds are caused mainly by adiabatic cooling of air below its dew point. So as per the classification, as I explained, there are high clouds, middle clouds and low clouds. Cirrus, cirrocumulus and cirrostratus, these are the clouds which are considered as the high clouds, whereas orthocumulus, orthostratus and nimbostratus, these are characterized into middle level clouds, and stratus, stratocumulus, cumulus and cumulonimbus, these are the clouds which are considered as the low level cloud. So the high clouds that ranges in that cirrus cloud that ranges 3 to 8 kilometers in polar region, 5 to 13 kilometer in temperate region, and 6 to 18 kilometer in tropical region. Whereas the distribution of cirrocumulus clouds is 10,000 to 25,000 feet in polar region, 16,500 to 45,000 feet in temperate region, and 20,000 to 60,000 feet in tropical region. So far as level clouds are concerned, altocumulus to nimbostratus, they range from 2 to 4 kilometer in polar region, 2 to 7 kilometer in temperate region, and 2 to 8 kilometer in tropical region. The clouds which are very visible to us, that remains concentrated from the Earth's surface to 2 kilometer in the polar region, that are known as the stratus, stratocumulus, cumulus and cumulonimbus, and from the Earth's surface to 2 kilometer in both the temperate as well as tropical regions. Now I will explain separately about different clouds. The first one is cirrus clouds. The high altitude detached cloud having fibrous, hair-like or silky appearance areas are called as cirrus clouds. They are composed of tiny ice crystals and are transparent and white in color, but have brilliant colors at sunset and sunshine. These clouds are indicative of dry weather. You can refer this particular figure and imagine what am I talking about. The second one is known as cirrocumulus clouds. Thin white patch, sheet or layer of clouds without shading, composed of very small elements in form of grains, ripples, etc., merged or separate and more or less regularly arranged. Most of the elements have an apparent width of less than 1 degree centigrade. So these type of clouds are known as cirrocumulus. Cirrostratus clouds. These clouds are generally white in color and spread in the sky like milky thin sheet. In fact, cirrostratus is a thin white veil of cirrus clouds. They are composed of tiny ice crystals which refract the lights of the sun and moon, and thus halos are formed around them. They are so transparent that the sun and the moon are visible through them. Altocumulus. These are white or grey or both white and grey patch sheet of layers of clouds, generally with shading composed of laminae, rounded masses, rolls, etc., which are sometimes partly fibrous or diffuse and which may or may not be merged. Most of the regularly arranged small elements usually have an apparent width between 1 degree and 5 degree. When they become thick sheet, the sun and the moon are obscured and they appear as bright spots behind the clouds. They do not form halos around the sun and the moon. They cover the sky partly or totally, or are smoothly distributed over the entire sky. They yield widespread continued precipitation either in form of drizzles or snow. So these type of clouds you may see in the sky. Altostratus clouds. Grayish or bluish cloud sheet or layer of striated fibers of uniform appearance, totally or partly covering the sky and having parts thin enough to reveal the sun at least vaguely, as through ground glass. Altostratus does not show halo phenomena. Nimbostratus clouds. These are grey cloud layer, often dark, the appearance of which is rendered diffused by more or less continuously falling rain or snow, which in most cases reaches the ground. It is thick enough throughout to blot out the sun. Low ragged clouds frequently occur below the layer with which they may or may not merge. Nimbo is from Latin word nimbus, meaning thereby rainstorm. They are associated with rain, snow and sleet, but are not accompanied by lightning, thunder or hailstorm. Another type is known as stratocumulus. Grey or whitish or both grey and whitish patch sheets or layers of clouds that almost always has dark parts composed of tessellations, rounded masses, rolls, etc., which are non-fibrous and which may or may not be merged. Most of the regularly arranged small elements have an apparent width of more than 5 degrees. They are composed of globular masses or rolls which are generally associated with fair or clear weather, but occasional rain or snow is not ruled out. Now next one is known as stratus clouds. Generally, grey clouds layers with a fairly uniform base which may give drizzle, snow or snow grains. When the sun is visible through the clouds, its outline is clearly discernible. Stratus does not produce halo phenomena except possibly at very low temperature. Sometimes stratus appears in form of ragged patches. Another form of clouds are known as cumulus clouds. Detached clouds, generally dense and with sharp outlines, developing vertically in form of rising mounds, domes or towers, of which the bulging part often resembles a cauliflower. You may observe that the sunlight parts of these clouds are mostly brilliant white, their base is relatively dark and nearly horizontal sometimes. So cumulus is ragged, they are very dense and dome shaped and have flat base. They are wool-pack clouds, masses and are associated with fair weather, but sometimes they become thunder clouds. Cumulonimbus clouds. Heavy and dense clouds with a considerable vertical extent in the form of mountain or huge tower. At least part of its upper portion is usually smooth or fibrous or straight and nearly always flattened. This part often spreads out in the shape of an vast plum. Under the base of this cloud, which is often very dark, there are frequently low, ragged clouds either merged with it or not, precipitation sometime in the form of virga. They show great vertical development and produce heavy rains, snow or hailstorm accompanied by lightning, thunder and gusty winds. Now after explaining different types of cloud, I will explain you precipitation, different process of precipitation. The process of continuous condensation in free air helps the condensed particles to grow in size. When the resistance of air falls to hold them against the force of gravity, they fall onto the earth's surface. So after the condensation of water vapor, the release of moisture is known as precipitation. This may take place in liquid or solid form. Precipitation in form of drops of water is called rainfall when the drop size is more than 5 millimeter. It is called viraj when raindrops evaporates before reaching the earth while passing through dry air. Now you might be thinking, what are drizzle? Drizzle is light rainfall with drop size being less than 0.5 millimeter, and when evaporation occurs before reaching the ground, it is referred to as When the temperature is lower than 0 degree centigrade, precipitation takes place in form of fine flakes of snow, and it is called as a snowfall. The next explanation is of moisture. Moisture is released in form of hexagonal crystals. These crystals form flakes of snow. Besides rain and snow, other forms of precipitation are sleet and hail. More about hail while studying thunderstorm. So, through the latter are limited in occurrence and are sporadic in both time and space. Sleet is frozen raindrop and refrozen melted snow water. When a layer of air with temperature above freezing point overlies a sub-freezing layer near the ground, precipitation takes place in the form of sleet. Now, next which you should understand is raindrops which leave the warmer air encounter the colder air below. As a result, they solidify and reach the ground as small pellets of ice not bigger than raindrops from which they are formed. Sometimes drops of rain are being released by clouds, become solidified into small rounded solid pieces of ice, and which reach the surface of the earth are called as hailstones. These are formed by the rainwater passing through the colder layers. Hailstorms have several concentric layers of ice, one over the other. So, now you may understand the differences among rainfall, virage, drizzles. I once again explain you, rainfall drop size more than 0.5 millimeter. Virage raindrops evaporate before reaching the earth's surface. Drizzle, its light rainfall, drop size are less than 0.5 millimeter. Mist, evaporation occurs before reaching the ground, leading to foggy weather. And what is a snowfall? Fine flakes of snow fall when the temperature is less than 0 degree centigrade. Now, what is difference between snowfall and sleet? Frozen raindrops and refrozen melted snow. These are mixture of snow and rain or merely partially melted snow. What are hail? Precipitation in the form of hard rounded pellets is known as hail. These ranges from 5 millimeter and 50 millimeter. Now, I will explain you different types of rainfall. The classification of rainfall has been done on the origin of rainfall, or I can say on the source of rainfall. So, on the basis of origin of rainfall, the rainfall can be classified into three main types. The first one is known as convectional rainfall. Second is orographic or relief. It is basically related to the mountainous area. And the cyclonic or frontal rainfall. Convectional rainfall. Now, what are the convectional rainfall? The air on being heated becomes light and rises up in convection currents. As it rises up, it expands and loses heat, and consequently condensation takes place and cumulus clouds are formed. This process releases latent heat of condensation, which further heats the air and forces the air to go further up. Convectional precipitation, that's the reason, is heavy but of short duration, and these are highly localized and is associated with minimum amount of cloudiness. So, if heat is concerned, where will it be associated? It is generally associated during summer and is common over the equatorial doldrum in the Congo basin, the Amazon basin, and the island of Southeast Asia. The convectional rainfall, as I explained, you can see that how the air, when it warms, it is going up and then it is releasing the heat, and the latent heat of condensation that is taking place, it is forming the clouds and then it is coming down in form of the precipitation. and as I said that basically it is related during the summer and equatorial region. Why equatorial region? Because equatorial regions are high and the amount of heat released by the equatorial region is higher compared to the other regions. Now I will explain you orographic rainfall. As I mentioned earlier that orographic rainfalls are generally associated with mountain. Why is it called orographic? When the saturated air mass comes across a mountain, it is forced to ascend and it rises. It expands because of fall in pressure. You may be aware that temperature and pressure are inversely proportional. So when the temperature falls, the moisture is condensed. This type of precipitation occurs when warm, humid air strikes an orographic barrier, a mountain range, head-on. Because of the initial momentum, the air is forced to rise. As the moisture-laden air gains height, condensation sets in and soon saturation is reached. The surplus moisture falls down as orographic precipitation along the windward slope. You must understand that the air, as I was explaining, the warm air, this warm air rises on the windward side, and this air, as this slope as I explained, receives less rainfall, and the leeward slopes that receives the greater rainfalls. So when the warm air that goes up, then their capacity to take moisture increases, and hence these leeward slope remain rainless and dry, and the area situated on the leeward side which gets less rainfall is known as the rain shadow area. Some arid and semi-arid regions are direct consequence of the rain shadow effect. For example, Patagonian desert in Argentina or eastern slope of Western Ghats in India. It is also known as the relief rain. For example, Mahabaleshwar, situated on the Western Ghats, receives more than 600 centimeter of rainfall, whereas Pune, lying in the rain shadow area, has only about 70 centimeter of rainfall. So that is the reason, that is how this process takes place, and that's the reason that when a mountain is there, then there is a difference in the precipitation. As I explained you, the windward side receives a greater rainfall, and leeward side, where the saturation, where the air gets saturated, that receives less rainfall. And on the leeward side, it is heated, that is adiabatically, and it is called as katabatic wind. Frontal precipitation. When two air masses with different temperature meets, turbulent conditions are produced. Along the front, convection occurs and causes precipitation. We studied this in fronts, as I mentioned earlier also. For instance, in northwest Europe, cold continental air and warm oceanic air converge to produce heavy rainfall in adjacent areas. So, front, frontogenesis, stationary front, cloud front, warm front, occulted fronts, all are related to this particular mechanism. Now, the next one is cyclonic rainfall. Cyclonic rainfall is convectional rainfall on a large scale. We will see this in detail later. The precipitation in a tropical cyclone is of convectional type, while that in a temperate cyclone is because of frontal activity. You may see this figure and can know that what are the frontal cyclones. Monsoonal rainfall. This type of precipitation is characterized by seasonal reversal of wind which carry oceanic moisture, especially the southwest monsoon, with them and cause extensive rainfall in South and Southeast Asia. More while studying the Indian monsoon, we refer or we explain the monsoonal rainfall. World distribution of rainfall as per different regions. Different places on the Earth's surface receives different amounts of rainfall in a year, and that too in different seasons. In general, as we proceed from the equatorial toward the poles, rainfall goes on decreasing steadily. The coastal areas of the world receive greater amount of rainfall than the interior continents. The rainfall is more over the oceans than on the land masses of the world because of being greater source of water. Between the latitude 35° and 40° north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing toward the west. But between 45° and 65° north and south of the equator, due to westerlies, the rainfall is first received on the western margin of the continents and it goes on decreasing towards the east. Where the mountains run parallel to the coast, the rain is greater on the coastal plain, on the windward side, and it decreases toward the leeward side, as I mentioned earlier. On the basis of the total amount of annual precipitation, major precipitation regimes of the world are identified as the equatorial belt, the windward slopes of the mountain along the western coast, in the cool temperate zones, and the coastal areas of the monsoon land receives heavy rainfall over 200 cm per annum. Interior continental areas receive moderate rainfall varying from 100 to 200 cm per annum. And the coastal areas of the continents receive moderate amount of rainfall. The central part of tropical land and the eastern and the interior part of the temperate lands receive rainfall in between 50 to 100 cm per annum. Whereas areas lying in the rain shadow zone of the interior of the continent and high latitudes receive very rainfall, as I explained to you earlier also, less than 50 cm per annum. So, seasonal distribution of rainfall provides an important aspect to judge its effectiveness. In some regions, rainfall is distributed evenly throughout the year, such as in the equatorial belt and in the western part of the cool temperate regions. So, now after understanding different types of precipitation, after understanding different types of clouds, you can understand one thing very well, that the mechanism or the process of precipitation is very much related to the topography of a particular region. Topography of a particular region actually forms different types, as well as it also maintains or disturb the mechanism of precipitation. So, precipitation is very important for the Earth's surface, as the farmers grow crop because they receive the precipitation. In other words, I can say that we are able to have our food because of the water. If the concentration of precipitation increases, that also leads to a flood-like situation. You are very well aware of the advantage and disadvantage of certain phenomena, and that is the reason that it is very important to create a balance. Unless you understand different processes, unless you understand different types, you may not be able to create a balance as a human being.